Couple weeks ago, a friend of mine had a job interview as a backend developer. He has test assignment and basically he has failed completely his test assignment due to application infrastructure setup, which took a little bit longer than he has expected. Also due to production deployment, and finally due to unexpected and prolonged power outage. And basically due to all of this, he has failed. Okay, so lesson learned. Let's try what we can do in order to help him with his next, or probably I hope next, test assignment and during his next job interview. So let's try within 60 minutes to set up complete development and production environment for a small web API service. And as soon as we already know that there are something we cannot deal with, we'll try to use only web browser plus couple tools from the Amazon Web Services. Let's see how far we can go there. So we're going to develop and deploy this. It's a name. This is name of the web API. Basically, this is just a simple web API which saves data into the Postgres database. Then also it sends some messages to the remote queue, and then receives these messages in different process, and finally writes some data to the Mongo database. As an entity we're going to work with, we will choose to work with something called category, and basically this entity has a couple fields like name and date. Okay, let's see what we have in our development environment right now. So all the code is written in the Visual Studio, and let's try to run it locally. So what I have here is a test application opened. It has API, and basically in the API we have some authentication and some category controller. With this category controller we can get some data, and we can create some data. All the logic encapsulated in the commands and queries, like categories, something to mutate data and something to read data. What else? We can run it locally. So let's try. Even a couple breakpoints. Seems good. Let's try to use Postman to authorize our user in order to do some requests. Also, let's try to, get list of all categories. Right now we have only one. We probably can create some, like this, new program category. Let's create some more. Monitor. Okay. Alright. Let's try to see list of our categories. Good. We even have a paging here. Nice. We can update some category. Let's try to get one. It's cloned 0 administration. Let's try update this one. Get again. It's update with something else. Basically, this is just a simple web API to do some CRUD operations and save data to couple databases. That's it. What else we have? We have different environments. Let's check environments. We have development environment with all the connection strings targeted to localhost, and we have production environment. And basically we need to run our app in production mode when we deploy it somewhere. What else we have? All the databases. Right now they are deployed elsewhere on database host providers. So let's try to connect to the remote databases. This is categories table. It is empty. This is some kind of log database. It is empty as well. Also have some data saved in Mongo. Actually, it's empty right now because we remotely didn't create anything. And we have all the build, all the application built in a Docker container. For the development, we use Docker Compose with the local resources installed. Here we have a Postgres database, we have a message queue, we have cache database, and we have Mongo. Beautiful. So all of this is ready to go and ready to develop any type of application with all the local infrastructure spinned up in a single click. We also have, what else we have? We also have ability to build our container locally. Let's try. Let's stop this one. Let's check our launch settings. In the Docker, we have application environment set to production. It means during the production we will connect to our remote databases. So let's try to do something remotely. I will start Docker profile here in Visual Studio, and let's see what it does. Here's our log. We start in production mode, which is good. Let's wait for the all preparations to be done. Seems good. What we need to do is get our port, and we can try to change our Postman environment from the just a project to the Docker instance started here. So let's try to authorize. Oops, what's wrong? Okay, port is different. Makes sense. 32. Okay, this correct port. Let's provide our port. Try authorize via Docker environment. Works good. Okay, let's get all categories, and we should see none just because there is nothing in the database. Let's create category. Okay, matrix. Nice. Let's update. Let's get it again. It's profound. I have no idea. Something like this. Let's check remote databases. The categories table has new, or actually updated category. Our logs table has some entry to create category and to update category. These two actions we executed via Postman. Also, let's check Mongo database. We have history with public entries. This is API calls executed now API, and we have three. We have login, we have API category create matrix, and we also have update request to the category with this name as updated value being recorded here. What we also have our communication or async communication via RabbitMQ. We have some records in other collection. We have category created, category updated, reactions. Basically that's it. We started our project against local and remote environment, and everything is good. Everything seems to work, so we probably can deploy it somewhere. So we check our Docker locally and we edit category via Postman, and we checked our remote databases. So we have local development environment. What we need to create is some kind of remote operations environment where it will be possible to get some code, modify some code if it's needed, where it's also possible to build container with our application and publish this container to some remote registry in order to then spin it up and make ready for a production. So let's see what Amazon Web Services could help us. First of all, let's create EC2 instance, medium one, and which is important. We need to get 20 gig of space because all the containers and build tools, they require some space. So let's go to Amazon. Let's start EC2, launch instance. Our project name is where? Project name is this one. Sounds good. It will be Amazon Linux, latest version. Everything is good here. So let's change our instance type to medium. We probably need to create new key pair. This one seems good. We need more space. Oops. More space. Check everything. Looks good. Let's launch this EC2 instance. It is running right now. Looks good. What else? Let's connect to our instance and see what we can do here. Connect. Copy. We probably need another one SSH client. So let's try to SSH. Good. Okay. What else? Let's create Cloud9 environment with this instance. New environment. Let's name it as the same as our project. Okay. Existing instance. For that we need to provide SSH keys. Makes sense. Okay. So let's go to our SSH keys, copy it to clipboard, paste it here, looks good. Okay. We also need our user, login name, our instance, I believe this one. This one. Okay. Oops. Oh, we need Node.js, makes sense. So in our new instance we need to install a couple of things here. This is wrong. Okay. Let's try create our Cloud9 environment once again. Good. In the same time we can check that we have Git installed. Let's also install Docker. Looks good. Let's enable our Docker. Start it. Let's add our user to the Docker group in order to execute Docker commands without sudo. Check our Docker instance, it's running, and we even can see version. Yep. So Docker is ready. What's here? We have our Cloud9 instance. Let's try to open it. Seems we need to install some software. Okay, let's wait. Okay, so our remote development environment is ready, and we probably can continue all our next steps in the web browser only, without Visual Studio and local computer and everything, and probably even from mobile phone or with absolutely anything which allows to connect web with a web browser. Okay, so let's try to install some packages for the .NET 8 on the remote computer. I will do like that. What else we need? We need .NET SDK. Okay, so .NET 8 is ready. Let's check version. Let's check list of installed SDKs. Looks good. Okay, so what we then need to do is to clone our project from the GitHub in order to continue development here on this remote computer. We have absolutely the same here. We have our API, we have our source code. We can modify it here. We can present it here. We can do any type of tuning with the local variables, build environments and everything. Okay, just a normal, semi-normal application development environment. Looks good. Let's try to build it. It's restoring packages. Okay, it seems it built locally. What we can try right now is to run this project. Obviously it will not be run just because we don't have any databases here installed on this Cloud9 instance on the EC2 computer, so we cannot run in dev mode, but we can for sure try to run it in a production mode, in a production environment. But instead of just running in a production, I'm going to build a container here locally and then run this container with a production environment also here remotely. Okay, it seems our container was successfully built. Let's try to run it. Nothing is here. Let's start our container. It seems it has been started. Let's, okay, here it is, 8 seconds ago. Let's check logs. Yep, started in the production mode. Everything's fine. Okay, let's get some information with a curl from the local instance of our application. Here it's in production mode and some weird server. Okay, seems good. Everything is ready to be deployed remotely, but before, let's stop our application instance. Exit it. Beautiful. Okay, so as soon as we have our container ready, we can publish this container to Amazon ECR. Let's see what it can give us. Let's go to container registry, create new one. Let's give a name of our registry the same as our project. What else? Everything seems good. We have our registry. We need to go here and get push commands. Seems good. Our registry. Oh, before we need configure our EC2 instance with AWS credentials. This is my user created in YAM. Like that. Okay. Let's add our registry. Okay. We don't need build container because it already was built. We need to tag container. Okay. And finally we can push it. Let's push our container to the remote registry. Good. What else? We are ready to go live. So now let's start our container with AppRunner. Create new service, container registry, Amazon. Let's find our registry. We can set it to automatic deployment. Service role, let's choose our role, go next. Service name, the same as our project, like that. Let's give it a little bit more memory. Environment variables, here we need to provide production environment. Okay, port, health check, permissions, everything good. Let's go next and create our application from the registry. Looks good. Deploy. Okay, it seems our deployment is ready. We can check logs. Seems good. What's here? Application logs. Our service is run in production mode. Seems good. And it's live. So with this URI we can invoke production ready instance of our web API. Let's try. So right here in a Postman we change our base URI and let's try invoked. Beautiful. Production IP strange server name on a remote host with HTTPS and with everything. Looks good. Let's try to authorize. Authentication works. Now let's see what we have in our remote databases. Here we have only one record. In the logs we have couple. Okay. So let's create new category. Create category. Send to remote instance. Protocol, category name protocol. Let's check categories remotely. Protocol. Let's check logs. Refresh. New one created. Let's check other database. Public. What we have? We have API request to create category with a name protocol, and we have category created with a name protocol. Let's try to modify this one. Update category. Actually, let's let's get it. Its name was updated. Verify in remote databases. Yes, updated. Messages recorded. And all databases updated. Category with a name. Okay. Here. Okay, seems to work nice. Deploy it with AppRunner. Okay, let's try to modify this code and create new feature. Let's say in our some of our API methods we would like to create new feature, and right now info API request gives us environment and server, and we would like to, as a new feature, add another one field with a current date and time. Seems good. So let's save our modifications. We can actually we need rebuild our app and rebuild and republish our container. So let's find commands to build our application. Let's build it here. Okay. Let's build our application. Looks good. Let's rebuild our Docker container. Rebuild our Docker container. Build done. We can run it locally, or we can right away just to publish our updated container to the remote registry. And as soon as it's published, and as soon as we have automation, then after republish, the AppRunner will update our deployed instance. Let's check our AppRunner here. It is deploying new version from the container registry, and let's wait for it to be redeployed. Okay, our new version has been deployed. Let's try our new feature with the new response field in the info API call. So let's try to execute new request, and we see our new field, so new feature has been deployed. Now, as soon as this one is production ready web API deployed to the Amazon Web Services, what we can do is we can try some performance tests. Let's check state of our databases. Here we have 9 records, 4 records, and in the Postgres we have 2 records and 4. Okay, let's try to execute some performance tests. Let's use Postman for that. Run. We will get categories, get all, get some with some additional data, get one. We will create and update, so we're not going to delete anything. Okay, so it will be performance test. Let's say with 10 users for 2 minutes. Let's ramp our API for 1 minute and start our testing. Okay, we're ready with the results. We even have some errors, which is probably good. Okay, bad request on create and on update, but in general we executed our requests with the following requests per second rate. In total it was average response time. Seems good. Let's see what we have in databases. In the categories we have some new data. Almost 500 rows. Okay. In the logs we have some category, created category, updated API requests. We record only mutations, we don't record GET requests here. And in our history database we have some records, some API calls been executed, and some data was modified. So basically that's it for this little demo. We can develop our application on the infrastructure installed remotely. We don't depend on local computer. We easily can deploy our API to production, and we in a way protected from any kind of disaster. As soon as we have mobile phone, keyboard and internet, we can tune our source code or modify it or create new one, build and publish with this amazing set of features. That's it. Thank you so much.